Okay, welcome to Programming Rainbow. In this video, we'll continue on the Yellow Snow game in SDL2 and C++. This is the 5th video, so if you want to follow along with this video, you can go to github.com, Programming Rainbow, and this one is Yellow Snow, CPP, SDL2. And you can git clone that repository, move inside the directory, and you can use whatever editor you like. So I'll just show you the code. And I'm just going to first show you the actual final product game running so you can see what it looks like. So you have this yellow snowman, and if you hit the yellow snow itself, it's game over. The spacebar will restart it, escape, or telling it to close up here will close it. And it's pretty simple, straightforward, but it does lots of different things. So in this video, we're actually going to let the player move. We loaded the player and created the player class in the last video. In this video, we're actually going to be moving him left to right, and we're going to use a different way. We're not using the pull event that we were using in a prior video. This one, we're going to use check the key state itself. So if you are just starting from this video, we're working with the source code in the SRC folder, but if you've just cloned this, it'll be the same as the source code in the 10th video. But since this is the 5th video, we're continuing on where we left off in the 4th video. So you'll want to copy the source from here, these, or just the whole directory, and just rename it or copy it however you want to do and make it SRC, and you'll be right where we are. Okay, so this is the video right here, or this code right here. If I recompile it, just the right here, just do a rebuild on it. This is going to show what we left off with in the 4th video. Okay, so we have our snowman loaded. He's sitting in the snow. He's in the middle of the screen, but we can't move him. Okay, so we are going to make him move. And the way that we're going to do that is we're not using this SDL pull event, because this captures key events. So that means when the key has gone from up to down, that's an event. Or when it's gone from down to up, that's an event. But that's not helpful when we want something to happen every single frame, because the key event happens one time. Even if your keyboard does a repeat like this right here, you watch, I'm going to press the A button, you'll see one A, and then you'll see multiple A's after it. That is kind of like a repeat. I think I'm not sure if it's hardware or software, but we don't want that. We want to just know if the key is in the down state. So SDL2 lets us do this. And we have a function that's going to give us a pointer into SDL2's internal array that represents the keyboard. Okay, so I know that's a mouthful there, but this is the function. If we put something that's not null in here, we're going to get the length of the array, maybe so we can hold it. I actually don't care about what the length of the array is. I just need a pointer to the array that exists internally. So we're going to be passing null pointer into here. This is returning now this pointer into the array. Now this is allocated on the heap, but we are not allocating it. This is something SDL has done for us. We're just getting a pointer to it. So we don't need to do any smart pointer or anything like that for this, because this is not being managed by us. This is being managed by SDL2. It's already in place. We're just getting a pointer to it. So that's what it is. It's going to be an array of uint8s. And this is going to represent these keys right here. These scan codes will actually be used to index into this array. So imagine if this scan code right here was, say, 0, that would be the first one. It's probably not 0. It's 4. But and B is 5 and C is 6, something like that. So we don't really care. We just want to say, is A being pressed or not pressed? So if it's not being pressed, it's going to be a 0. And if it is being pressed, it's going to be a 1. So it's kind of like a Boolean, even though it's not being stored as an actual Boolean, it's being stored as a uint8. So this is our pointer to an array of uint8s. And again, it's representing our keyboard. And this is just going to tell us what the state of it. It's not going to tell us an action from up to down or down to up. It's just going to say, what is it right now? Is it down? Okay, I'm still moving this frame. Next frame, is it still down? Okay, I'm still moving. It's not concerned with events. Okay, so that was a lot of information about that. So let's just do it. So what we need to do is I'm going to hold on to this pointer in the player class. So I'm just going to call it key state. That's going to be what I call this. And then I'm going to use this in the player init to populate that. And again, we're just getting a pointer to something that already exists. SDL creates it for us, and we are not worrying about the memory management of this. This is not something we're creating. It's already been created. So I'm going to close this down here. Exit. There we go. And let's go to the player. And what we need is this key state. So this is the const uint8, because we're not changing anything that's in this array. We just want to know what's in it. And we're just going to call it key state. So we have that. I'm going to set it to null pointer up here. All right, null pointer. And we are going to have an update. And it's going to be it's going to be called from game, so it needs to be public. That's probably good enough for now. We are going to be adding in some inline methods here, but this is just fine for just now. Oh, I have something here changed. Oh, yeah, okay, no. I was typing A on the screen. In the init, we need to populate this pointer now. So we're going to use that function that we were just looking at right here, this SDL get right here. I'm just going to copy that. Say this, key state, and we're just using null pointer here. The size of this is not relevant to me. I'm just going to use it. So now that we have this, we can go into update, or we can create update right down here. And the way that we're going to use this is just by using an if statement and then using the scan code. Let me show the scan codes again. All of these. And I'm not going to look for it, but there's an up and a down, or left and a right, which are the arrow keys. And you could also do ASWD as well. And so basically they all look like this, but then space or up or down or left, right, and the letters are all the same. So that's the SDL scan codes. So we can just very simply say if this key state, and now we can just index the key state, which is an array of uint8s, with one of those scan codes, and those scan codes are used as the index. SDL scan, right? And if we want to move to the left, yeah, I do have left first. We could put left. And we could even add, if we pressed A as well. So we could say, not add, sorry. We're going to use the OR operator. So if the left is pressed, or if the A is pressed. So it's going to be the same, this key state, SDL scan code, and this one will be A. Since if we're using the ASWD keys, A represents left. So if we've pressed any of those, we want the rectangle that represents the player that we've set up in a previous, we've set the X of it to the center of the screen. We want to subtract a number from the X because we want it to move to the left. And the origin of the screen in SDL is in the top right. So this is 0, 0, 0 for the X here, and 0 for the Y. Y gets bigger going down, and X gets bigger going to the right. So we want to move left. We want X to get smaller. So we got this rect.x. And we are going to subtract. I'm using the subtract equals. That means it'll just subtract whatever was in there. So if 50 is in there and we tell it to subtract 5, it's going to be 45 now. So it's a minus equals. And I'm going to use player vel. It's not created yet, so I'm going to create it. That's player velocity. Okay, so we better create that because it's going to complain about that. And I'm going to put that in main as a const expr right here. So you can change it very easily. Since we are using the rectangle, those are ints in the rectangle. So I'm just going to use an int to subtract. So we'll say player velocity. And I'm just going to say 5. So we have about 60 frames a second that we're doing thereabouts. So if we move 5 pixels each frame, we're going to have about 300 pixels movement in a second. That's the speed. So think about it as 300 per second. Later on, we're going to be using delta time and everything else, but right now this will just work good enough. Okay, so back to the player. Now we have our velocity. And so we can do the exact same as this for the right. And I'll just do this first and then check going off the screen later. Now I'm not going to do an if else, and the reason why is if this one is true, let's say I'm pressing left, I want it to move left. If right is true, I want it to move right. But if I use an if else statement, if I press left and right, I'm going to move left because the if on the left will be true first, the else will never be checked. So if I press both of them, I actually don't want it to move. And what it's going to do in the update is it's going to move it twice. It's going to move it one way and then back the other way, which represents not moving. So each of these are going to be in their own statement. Right here, we need to add. Okay, and we also need to call this. So we have this method. It needs to be called from game. And we don't have a game update yet, so we're going to create that as well. And this can be private. It's going to be between events and draw. So all of our updates are going to happen here. And we go into game. Game update. Whoops, I just did something. And right now, the only thing happening in here is that we're updating the player. So this player update. So that's going to turn into a one-liner when I save. But there'll be more stuff later happening there. So we should be able to try this out now and see what happens when we press different keys. Okay, so I'm going to press the right key and nothing's happening. Press the left, nothing's happening. Pressing A. I'm going to press both of them. Nope, just nothing's happening at all. So I've done something wrong. Let's look at the code. Player update. Velocity is 5. I am calling it. Oh, you know what I'm not doing? I'm not calling game update from the main loop. So I did make the update method, but I didn't call it from here. So it goes events, update, then draw, and lastly our delay. So I didn't call it yet from here. So it's not actually getting called. So this is our main loop. It says, hey, game update itself. And inside our game update, it's going to tell each separate thing to update as it needs to be updated. Okay, I'm just going to do a run. It should just rebuild the part that it needs. Okay, left, yep. Right, perfect. And D, yes. A. Now if I press D and right, yeah. If I press left and A, okay. Now if I press A and right, which are opposite, nothing happens. Cool. If I press left and D, which are opposite, nothing happens. If I press left and right, nothing happens, and A and D. And then I let go of A and it moves. Now I'm pressing them both. I let go of D. So everything's working correctly. Everything, if I press opposites, it doesn't move. Otherwise, it's moving as expected. And you see it like little bit of a hitch. I think that's just because we're not using delta time, and one frame or something of the capture may be, in between. It's not a big deal right now. So we have this one problem though, is we can go off the screen. I actually want to prevent the snowman from going off the screen. I want to stop him when he gets to about here. And over here, I also want to stop him when he gets to about here. And we have another problem is the snowman, I want to have him flip directions. When he moves to the left, I want to have him looking left. And when he moves to the right, I want to have him looking right. So we want to change the way that he's doing that. And we also want to stop him from going off the screen. So those are two things that we'll do. So let's deal with the direction that he's facing. So right now we're using SDL render copy, but there is a more feature rich one called SDL render copy X extended. I'm not sure, but it gives us options to rotate things, to flip things, and also decide where the center is. So it's doing the same as the old one. The old SDL render took a texture, takes a source rectangle, a destination rectangle, but then we get three new items here. We can rotate them like around in a circle or something, left or right. We're not going to use it, so I'm just going to leave that to 0. We can decide where the center is. And if we put null here, let me check it. Center. If we put null here, it's going to use half width, half height, which is great. That'll actually be the center of our texture. So that's perfect. So I'm just going to put null there. And the last one is the one we're interested in. This SDL render flip. And I can click on this. I've already got it open. So we can set it to not being flipped. We can set it to flipping horizontal or flipping vertically. So we're going to flip it either horizontal or none. So that'll let us look to the right or look to the left. If we flip it horizontal, it's going to look to the left. If we say none, it's going to look to the right. So these are just what we put right here, basically. I'm not sure if these are in enums. So we're just going to use those enums in conjunction with the render X, copy X, to flip him when he needs to be flipped. So what I'm going to do is I'm going to hold let's see, is this enum I think enums are ins in C++. I'm not exactly sure, so I'm going to check my notes. Actually, I just use the type. Okay, so I'm just not even going to worry about what it is under the hood. I'm just going to use the actual render flip as the type. So back into the player class, I'm going to add, and this one is just going to be SDL, is it render flip? And I'm just going to call it flip. Yeah. And we will set it to SDL flip none so that it's not flipped by default. So flip here will be SDL flip none. Put a space there. It's render flip, not render flip. Okay, so I have this variable now, and it's already by default not flipped. So let's change the draw. So this right here is almost the exact same, except we need to change this to EX. Yeah, and we can look here, and I'm interested in what is passed here. I wish it showed, so we can just flip over to here. So angle, that's 0. This is null, and this is the flip. Okay, so 0, null, pointer, and the flip. So 0 for our angle. Oh, it showed it to me there. That's nice. I think for some reason there's not a key combination for C++, at least that I have set up working properly, where I can make this hover pop up. And I haven't dug into why that's happened. So it does it automatically. But when I want it to do it, the key combination for NeoVim doesn't seem to work for this language. And I'm not sure why. Or maybe it was a bug, or I haven't looked into it. So I just, haven't figured it out yet. But anyway, so 0, we're going to put null pointer, and then there's our flip. And this is this flip. So this is going to allow us to flip. So when we go into here and we're going left, we can just set that. Flip equals SDL flip horizontal. And then when we're going right, we can tell it that it's set to none. Okay, so that should make us point in the right direction. Okay, and perfect. We can see it's even not, it's flipping centered. So that's great. So the next issue is we're going off the screen, and I don't want to go off the screen. So to do this, I'm going to make some offsets, because let me load up again real quick. Oops. Let me show this. So imagine this image that I've loaded here, the right side of the image is here, right here where the snow is, and the left side is right here. So there's a box, at least assuming there's no extra white space or empty space in this image, there's at least a box from here to the snowman's head to here, and then also over to here. So that would mean when he got to the edge of the screen, it would be right here, and I don't want that. I actually wanted to think about his head as being the box. So I need an offset so I can move him closer. And I need the same thing over here. So I've just used trial and error again to figure this out. You can adjust these numbers. I'm just going to show you what I have. I think it's like 42 and 47 or something like that. So we're just going to go back to the const exprs again. And I'm going to call these offsets. And I'm even going to give a top offset, because when this flake hits his head, you know what? I'll leave it for that time. So I'm just going to add in the offsets for the left and the right now, which is going to be 47 and 43. Player left offset. And I'm going to make the left offset be 47. And again, I just tried numbers until I eyeballed it and it looked right. You can adjust these if you want it to be different. Right offset. And this one is 43. So these, I'm just thinking about these as offsets to the rectangle. So when I go over to player, I'm not going to put it in here. I'm just going to put inlines right here in the actual player class, because they're small. They're small little methods. So I'm just going to inline, like to get the left, to get the, well, not the top yet, but to get the left and the right, and set left and set right. And these don't need to be public. I have them as public. Oh, they are public, but the sets don't need to be public. Okay. Yeah, that makes sense. So it's going to be inline. And this is int. This is just going to tell me where my left offset is going to be, is what I'm doing here. So I'm going to make it const, because I don't actually want to change the value. I just want to return it. So I'm going to return this, and then the rect.x, but then I'm going to add the offset. And this is going to be, if I want the left of it, I actually want it more off the screen. So I want to think about where the left side of the head is, not the left side of the image. So I need that offset in from the image. So the player left offset. And we need a semicolon there. And that's going to be that. So that's going to basically, when I call this method, it's going to tell me where my imaginary left is, not where the actual left of the image is. Whoops, that's not right. So this rect y, and this one is just going to be the right. I need to get the right side of the actual image. So I need to add the rect width and then subtract the right offset from it. And that's going to give me the right side. So these two normally would just give me the right side, but this gives me the adjusted right offside. And this one would give me the left side, but this gives me the adjusted left side. I also want to be able to set, not setting it based on X, but setting it based on the offset. And I'm going to put this as a private. So this will be to set it, set the left, set the right. Set left and so this rect X is going to equal, this is, if I need to set my snowman to the leftmost place on the screen he's allowed to be. If I need to set my snowman to the rightmost place he's allowed to be. So the leftmost place he's allowed to be would actually be 0. Setting X to 0 would make it where the whole image is on the left, starting at 0. But I actually want to subtract away the offset as well to move him off the screen until his head is touching. So I'm going to just set this to negative player left offset. So I hope that makes sense. This is basically 0 minus left player offset. So if my snowman picture was here, but his head was here, this is 0, but I need to subtract the difference between the edge of the image and his head. So it needs to move off the screen to the left. And the same thing with the right. I don't know why I have 2 spaces here. This should not be Y here. Everything happening is on the X, not the Y, so there should be no Y going on there. So the right one, I'm going to take the width of the screen. I'm going to subtract the width of the image. So now my whole snowman's on the screen, even the part that the extra part. And then I'm going to add back into it the offset to move it, adjust it to the right. If that makes sense. So first it's going to be equal the window width. And then I'm going to subtract the width of the full image. And then I'm going to add back to it the offset for the right. And those two methods will set my player to the leftmost or to the rightmost. And what I'm going to do is I'm going to check it. If it's past it, I'm going to just use the set to set it. There is a top one. I'll get to the top one in a little bit. But let's just use these two real quick. So in player update, So instead of checking if X is less than 0, if X has gone off the screen to the left, now I can check if the left is off the screen. And if it is, I can set left. So it makes it really easy. So I'm going to do it right here after I've initially moved it. I'm going to say if this left is less than 0. So if the left side of my head instead of the image is off the screen, then I want to make sure that the left side of the head is just touching the edge of the screen, not off of it. So if this player is, if the left part, which is going to be the head, if it's gone off the screen, then I'm just going to use my set method. I'm going to set the left. So that makes it simple. So I'm going to do the same. This left. Sorry, that's a method call. So I'm going to do the same thing for this on the, what am I doing here? Yeah, right here. And I'm going to do the right and set the right. Okay, so what's going to happen here is if my left offset has gone to 0, it's going to say, hey, you've gone too far left. I'm going to reset you to the left, to where as far left as you're allowed to be. And the same thing on the right. So we should be clamped to the screen now. And the reason why I made methods for that is because I'm actually going to use those again another time. So I do need to know when the left. See, I can't move anymore. And to the right. Oh, we have a Houston. We have a problem. That's not right. Well, it works on the left, but not the right. So I've made a mistake somewhere. Yeah, it's this 0 right here. This should be window width, because that's the right side of the window. Yeah, so I've definitely screwed up. It just jumps. Yeah. So what did I did? This right here, it should be larger than. Yeah. That's what I get for copying the code from above. Okay, there we go. And if we look here, the eye, there's a little bit of white in the eye. Or let's look at his mouth. The mouth, the little circle is like half drawn. So I think the left side is too aggressive. And this is going to depend on what system, you can make minor adjustments. It's not really a big deal, but we can change it a little bit. So the left side was too aggressive. Let's set it to 5. It probably depends on what window manager I'm using, how it draws. But also this is SDL3 under the hood that I'm using. So I think that is affecting things as well. Yeah. I think it affected the height of the snowman that was on the screen, because I'm on Arch Linux, and its SDL2 implementation is actually using SDL3. I'm just going to set these both equal. So it does act differently. Okay, it's kind of there, the little bit of it, and there. Yeah, it looks about right on both sides. So I think if I was just using SDL2 properly, it would need to be the other numbers, and this would probably be 74. But since I'm using this newfangled version, the numbers are slightly different. Okay, so this basically sets up the player movement, and we can use A or D, left or right. I want to do one more thing before I get out of here is I want to set the window icon. So we have loaded an image before that loaded it directly to a texture, but this time we're going to load to a surface. And the reason for that is the SDL free set window icon, SDL set window icon, it needs a surface. So it needs the window and it needs the surface of the icon. So we're going to do that real quick. And I'm going to put this in the initialize SDL. And I'm basically just going to give it a unique pointer that's going to automatically allow it to go out of scope. So because I'm doing C++ 20, we're using unique pointers here. I'm going to set this up as a unique pointer, and it's a surface. Let me just show you the surface again real quick. So this is the function that we need to call. So we need a window and a surface. So this right here, image load, instead of image load texture, this will load an image to a surface, which you normally don't want to use because surfaces are not hardware accelerated like textures. But for setting the window icon, that's what we need. So this is going to load. It just needs a file name. It doesn't need a render because it's not hardware accelerated. So it's just a file name. It returns a surface, and we just check the surface. If it's null still or null pointer, then it has failed. So just like the loading of the texture, except we don't need the renderer here because it's just a surface. And this is going to be temporary. I'm not going to hold on to this in the class. So I'm just going to do it straight right here. So the type of this is SDL surface. And since it's a unique pointer, we need to give it the type of the custom deleter. So we do the decal type, and this is going to be, it is SDL free surface to get rid of a surface. And we're going to call this, I called it icon surf, but I'm actually creating it right here. So icon surf for surface. And I'm just going to create it right here. So it's going to be image load. And we just need the name of the image that we're loading. And what I'm going to do is I'm going to pick the yellow snowflake over here. So right here we have yellow PNG, which is the yellow snowflake. And I'm going to use the relative path, so it's in the images folder. I do need to add in the deleter, which is SDL. I know we told it the type of the deleter, but now we have to actually give it the deleter, which is free surface. So I know that's a long one there because we're actually declaring the unique pointer, which is this whole thing right here. Here's our unique pointer, and then we're immediately, it's not going to be set to null pointer. It's immediately being set. So now we can check to see if it failed or not. And we're doing that just by checking the pointer to see if it's null still. So this one is called icon surf, and it's not a this because if it was this, it would mean it was a member variable of our class. This one is just being, the pointer is just on the stack here. I know it's pointed to something on the heap, but the actual pointer is just on the stack. So it's going to go out of scope immediately at the end of this method call. So it's going to be very temporary. So it's icon surf. Again, it's not this. And what's would be really confusing is if it was a this, I could leave the this off, and now I'm confused on whether when I have something, if it's a local variable or if it's a member variable, and I don't like that. That's why I explicitly use this when it's a member variable. Okay, so error, and I'm going to say creating surface. And this is coming from image, although you can also use SDL get error. It's the same. So that is going to basically populate this pointer. If not, we have a problem and we are getting out of here. So now we're going to use that function here to set the window icon. So now we have our surface. We can just use this, and this doesn't even return a void. It's just void, so it doesn't even matter. We don't need to check it. So we have a window pointer, which is called window, but it's this window. And we need to unwrap it because we are dealing with a pure C function here that doesn't use smart pointers. And then this one is the icon surf. And we need to unwrap it. Okay, so that's all we should need right here. So when this init SDL method goes out of scope right here, this pointer is going to clean itself up. So it has this memory allocated to it from this image load, but it's already has its custom deleter, which is SDL free surface. So it's going to delete itself. It's a bit complicated. I have the same course in pure C, and it would probably make sense if you follow the C course, if you don't understand what exactly is happening with these smart pointers and whatnot, because this SDL is a C library, but I'm using C++ 20 style coding to interact with it. Okay, so let's run this and see if we have an icon. Okay, see right here we have a snowflake, and I believe, yeah, down here, sometimes the flake is here as well. The flake is here. And if I were to not set this right here, it should not be there anymore. And yeah, we have just this X because I'm in X11 right now. And down here, the X. So that should be it for this one. Let me just go over what I've done here. I'm going to delete this. That doesn't need to be there. So we have basically got a pointer to the internal SDL array for the keyboard. Right here, this keyboard state, it's just a pointer to it's just an array of uint8s. And they're just zeros or ones, really, that's in that array. I'm just initializing it to null pointer here until I populate it in the init method. And I also have this SDL render flip, which is either going to be set to SDL flip none or SDL flip horizontal. Yeah, and player here. We've changed the draw to have this extended options where 0 is for the degrees that it is tilted. A null pointer is making it flip across in the center of the image, not on the left or the right. And then this actually sets it whether it's flipped or not. And we are setting that here. So let's talk about this. We have the key state where we are indexing the array with whichever one we're looking for. If it's not being pressed at the moment, it's going to be a 0, which is false. And if it is being pressed, it'll be a 1, which is true. So we're saying if this is 1, or if this is 1, either one of them, if either one of these is 1, this statement's going to be true. And that means we want to go left. So we are decrementing by player velocity, which is 5. And then we have these inlines set that we'll look at in a second here. If we're going left, we are flipping it horizontally. If we're going right, we're not. And we're doing the exact same thing for the right. We are using the right key or the D key, and we're adding the player velocity to the rectangle X that we're using here, the rectangle, so it knows where to draw it. Let's look at these inlines. So we have a couple inlines. This one is just returning whatever are offsetted, with the, let's just look at it real quick. So the snowman right here, I'm not interested in this bounding box right here, which is the rectangle, which goes right here from the picture to his head. I'm not interested in this. I'm actually interested in this bounding box around his head. So I've offset here and offset here. So when I have the left, I can offset it in to get my true left to my head. And when I have the right, I could subtract in the right to get that. So basically, to get it to stop there and to get it to stop over here, I'm also going to use this when finding out if a flake has collided with him. So that's why I have them as inline methods, so that they can be called from game to check a flake up against the left or the right side of the head. So that's why they're here. That's why it's more complicated. And since I already have this in place, I just use this too to be lazier in the code to set it, you know. But why I'm here, I'm going to put the top, and let me show you again here. Now, his head is round and the flake is round. So if I were to just check his head against the bottom of the flake, right here it would collide, which is fine. But what if it was over here? It's round, his head is round, the square of the box is here. So that point here against the flake's box would mean the flake is here, not even looking like it's touching him, and it would say it collided. So what I've done is I'm offsetting. This flake is 32 pixels tall, and I'm going to offset. I'm going to make the flake have to come halfway in to his head, or halfway the flake depth into his head. So it still looks like, even when it's over here on the side, it looks like it's colliding correctly. So I'm going to have a top offset too. That is 16. I'm just going to set that up now because it's in my code. And this is going to be in main. It's not in this video, but the code is already set in this video. So I'm just going to do it. Top offset, and I believe it's just 16. So I'm going to make a inline as well for that. I will be using this when checking the collision of the flakes later. So this top one right here, yeah. This is int as well, and it's going to be just top. And this one is going to return just y, which is the top of the snowman, plus the offset. That'll just move it down into his head a bit. Rec.y, that will be the very top of his head. And then I'm just going to move it down 16 pixels. Okay, and this should be a return. There we go. So I'm not using it just now, but it will be used later. So I'm just putting it in place. Okay, so that's everything on that. And let's just look at the one last thing. We've used a new method here, but it's very similar to the other one because we have this image load texture. Where is it? It's in the load media. We have this image load texture, which is from the image module that loads it to a texture. This takes a render and the thing, the file path. So this time, since we just need a surface, it's image load, which is right here, image load, and it just takes the path. I'm just putting it in a unique pointer with its own custom deleter, which is the free surface. And so right away, I'm just checking to make sure it did happen. And I'm not storing this in the class. So it's just local. It's a local variable, local pointer. Checking it to make sure it didn't error. And then I'm using it, if it hasn't errored, I'm using it in the set window. And even though this is a member pointer, this is a local pointer. Since they're both smart pointers, I need to use the get method on them to unwrap them and get the raw pointer because this is a C function. I hope that was entertaining or educational. You learned something. If you have any questions, you can ask them in below the video. Okay, so I think that's going to be everything. Have a good day and goodbye.